When you look at the evening sky, away from bright city lights, you can appreciate what our ancestors saw every night of their lives. The sky is bursting with stars. Some are so bright they'd stand out like beacons. Others are dim. Most are crisp points of light, but some seem blurry. These blurry stars are not individual stars at all. Some are, in reality, distant galaxies, many like our own Milky Way. If you live in a city with large amounts of street lighting as well as tall buildings, you can only see the brightest of stars in our own galaxy. Out here, when it's dark, you can actually see the band of the Milky Way, which has been called the backbone of night. Even under the best conditions, the human eye is not sensitive enough to see more than a small portion of the stars in the sky. To really see what is out there, we need a telescope. If we can see 10 stars in a given patch of sky, a large telescope will reveal 100, 1,000, or possibly 10,000 more. Telescopes don't make the stars look any bigger. It just allows us to see the dimmer ones. But most are galaxies, great collections of billions of stars like our own Milky Way. They looked fuzzy because they were far away. But how far? No one knew. We now have a better understanding of the distances between us and the billions of galaxies in the universe. Galaxies that come in all shapes and sizes. By analyzing the color, brightness, and motion of stars, scientists built up an image of different types of galaxies, including our own Milky Way. It is a flattened disk about 100,000 light years in diameter. Surrounding it is a sphere of stars, a common feature called a galactic halo. The Milky Way is a spiral galaxy. Seen from above, it would look like a pinwheel rotating around a bulging central hub. Clusters of aging red giant stars give the hub its pale reddish color. Bright, hot stars in the spirals make them appear blue, but there are clusters of yellow stars like our own sun here and there as well. Our solar system is in one of the spiral arms, out about 2/3 of the way from the center. Mixed in with the stellar spirals are vast clouds of gas and dust. This matter was blown into space by dying stars and may collect again to form new stars. Some of these clouds are still spreading, away from an explosion that propelled them into space, leaving behind a remnant, the core of a once great star. A neutron star is one such remnant. Its core is composed almost entirely of a tiny particle of matter called a neutron. Neutron stars are so dense that 1 teaspoonful would weigh 50 billion tons on Earth. Some neutron stars are known by another name, pulsars. These stars get their name because of a regular pulsing beam of energy that they emit.
The fact that this big, slowly spinning star collapses to form the tiny neutron star makes it turn faster and faster. It also intensifies the magnetic field of the star. And what you find is, it's an observed fact, no one ever theorized these things would exist. What you find is that you have a pulsar, and that means the magnetic field is somehow channeling high-energy particles that produce radio waves that come out in 2 lighthouse beams to either side of the neutron star. And as the neutron star is turning, the pulsar is turning, these lighthouse beams sweep around space. And if they cross the Earth, then every time when a lighthouse beam comes by, it shines on our radio telescope for a fraction of a second, and we call it a pulse. And that's what a pulsar is.
Not all the clouds that we see in the Milky Way are spreading away from an exploding star. Some clouds are converging. They may become stellar nurseries, where new suns and new solar systems arise. Of course, what draws our attention when we look at the Milky Way is the abundance of stars. They come in various sizes and stages of development. There are young stars, middle-aged stars, and dying stars. Among the dying stars are a group called red giants. They're called giant for a good reason. A red giant is so big that if one replaced our sun, it would swallow Jupiter and Saturn. Others are called blue giants. These are young stars that are so bright and hot that the Earth would have to orbit well beyond Pluto to remain cool enough for life to continue. Yellow stars are numerous, and so are white dwarfs. Our sun has a lot in common with both. Right now, it is a yellow star, but it will become a white dwarf toward the end of its life. We'll return to the Practical Guide to the Universe on the Learning Channel.
Connections 2, Sunday at 8 on the Learning Channel.